Hello, Professor. This is Dylan Kelly, and today I will be reviewing acid and base titration. Titration is a method of using a known concentration of a solute to figure out an unknown concentration of a second solute. Since today is only part one, we will be dealing with acid and base neutralization using titration. And we have three aspects of this experiment. We have our analyte, which is KHP. We have our titrant, which is sodium hydroxide, and then we have our indicator, which is phenolphthalein. So to get things started, you would first have to prepare your primary standard, and that would be KHP. You would measure it out to 0.3 grams. It should look like a white fine crystal powder. And you would then add it to your Erlenmeyer flask and add 50 milliliters of deionized water. Before we do that though, we have to quickly find the amount of moles in KHP to get started on this experiment. It's a pretty simple equation. You just take the 0.3 grams and put it over the molar mass of KHP to get 1 mole. And you calculate that in your calculator and you would get 0.00147 moles of KHP. The second step is to prepare your secondary standard, which is the sodium hydroxide. It is very hydrogenic, so all you need is 2 pellets. Put it in a 500 milliliter solution in a 1000 milliliter Erlenmeyer flask, and you start to blend it up. While you let that sit, you start to prepare your burette. So by preparing the burette, you put it in some burette clamps. It's a pretty simple process, and you then, make sure everything's working right. And you would then take the sodium hydroxide and flush it out. So doing that would get rid of any potential air bubbles that could increase the amount of molarity in our sodium hydroxide, which has a hypothetical molarity of 0.1. Before you get started on the experiment though, we have to prepare our indicator, our phenolphthalein. So what you would do is you would put 2 to 3 drops inside the 250 milliliter Erlenmeyer flask. It is clear when it's with acid, but when it has a base in it, it starts to turn pink. So after you clean out the burette, you start to take your sodium hydroxide and put it into the burette. You do not open the stopcock yet, however. After you see it fill up to the 50 milliliter mark, you start to slowly open up the stopcock until you start to see color change. Note, you have to be mixing it a long way. When it gets to the certain point where you start to see pink, you know you only have a certain amount of drops left. So you can do 1 or 2 things. You can do half drops. This is the best method to get it to exactly the result you want. And when it gets to the way you do that is you open the stopcock, and as a drop is forming, you proceed to spray it with water, because water will not affect the indicator as it doesn't have a pH that will affect it. However, once you get that drop in there, the concentration should look like this. This is our end point. It is not breaking over the end point, or it would be a lot darker. But after that, you would then take the starting value, which is 50. Then you would see your remaining value, which in our case is 36. So you would subtract 36 from 50, and you get the volume of sodium hydroxide being 14 milliliters. Now, you can plug that in to find your molarity. So as we see here, we have 3 grams of KHP. You find that it's 0.0014 moles of KHP. By the way, that is also the amount of moles of sodium hydroxide, as they have a 1-to-1 molar ratio. After you get to that point, you then have to convert the milliliters into liters, which is a very simple process. You just divide 14 by 1,000 and you would get 0.014. So after you plug everything into your calculator, you should get a molarity of 1.05 molarity of sodium hydroxide. And like I said before, our moles of sodium hydroxide is 0.00147. I think that there was a slight increase in the molarity as compared to what our hypothetical value was, due to there potentially being some dirt or trapped air bubbles in the burette that we might not have known of. However, the difference wasn't too extreme, but we will use this variable in part 2 that I will be posting in a couple of days. Thank you.